Hello friends, myself Prof T S Vandali. Today I am going to explain the projection of solids on square prism. In the previous lecture I explained the square prism resting on HP on one of its edge. So today I am going to explain the square prism resting on HP on one of its corner equally inclined to HP. In our question bank with solution, the problem number second problem it is a square prism 35 mm sides of base and 60 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests makes equal inclinations with HP. Draw the projections of the prism when the axis is inclined to HP at 40 degree and appears to be inclined to VP at 45 degree. So first, before drawing the projections of this square prism, we are going to think whether the square prism is resting on one of its corner on HP or resting on one of its edge on HP. So we have to think, then we are going to start. But in this problem, the square prism resting on HP on one of its corner. First we are going to draw the XY line, and you have to mention that HP and VP, above the XY line is VP and below the XY line is HP. Okay. Next, the condition is resting on one of its corner means first we are going to draw the square prism in this manner. First to consider the corner. So this corner we are going to consider first. Okay, corner, and this corner, these two sides are equally inclined to HP at an angle of 45 degree, means 45 above, 45 below, total included angle is 90 degree. Okay, this is the condition of square prism resting on corner. Their two sides are equally inclined to HP. Next condition is in the front view, whatever the height of the prism is given, that height is 60 mm. That axis makes an angle of 40 degrees to HP. That axis of the square prism is tilted at an angle of 40 degrees to HP. This is the second condition. In the third condition is their axis, whatever the second position you obtained in the second position, that top view, that apparent length of the second position top view, that axis is tilted at an angle of 45 degrees to VP. So these are the three conditions we are going to mind before drawing the projection of the square prism. First, to draw the square prism resting on corner on one of its corner equally inclined to the HP. So next we have to name the each corner by the text. We take it that top face, that square prism is having top and bottom faces. Already we had seen that square prism how it is. Okay, it is having two faces, top face and bottom face, and it is surrounded by four rectangular faces. But in the top face and bottom faces are square in nature. That top face four corners are represented by the top face P, Q, R, S. These outside bracket what I had written, that is P, Q, R, S are the top face. That is when you are viewing from the top view. Now I had drawn is, it is the top view. That top face is clearly visible. So we have to write all the four corners of the text outside the bracket, and inside the bracket I had written A, inside bracket B, inside bracket C, inside bracket D. Why I am written inside the bracket is when we are viewing from the top in the top view, that bottom face is not visible. So that is why we are going to write inside the bracket. Okay. Next, just draw the diagonals from the opposite corners. You are getting the intersection point at the exactly at the center of the top view. that is represented by the text O1 inside bracket O2. O1 is the top face center and O2 is the bottom face center of the square prism. Then we are going to draw the projections. Okay, you have to mention in the problem the height of the prism is 60 mm. From you project the center point O1 inside bracket O2. Okay, you have to draw the height by considering chain type line or thin dotted lines, that is the axis. Okay, you have to mention the height of the prism is mentioned is 60 mm. Then you project from each corners the projection lines in the upward directions. You have to construct the front view. In the front view, that the two corners, this is S inside bracket D and Q inside bracket B are in the same line. So in front view, this corner P inside bracket A is visible, so you have to draw the thick line, and R inside bracket C is visible, you draw the continuous line. And these two corners, this Q inside bracket B is not visible, this front corner or front edge S inside bracket D is visible. So in the front view, it is represented by the continuous line. It is overlapping with the axis of the square prism in the front view. Okay, in the last class, that resting on edge, that axis line is visible. In this, that axis line coincide with the front edge. Okay, next you have to name the each corners. As in the top face corner, it is P becomes P dash. So in the front corner top face front corner is S becomes S dash. Okay, inside the bracket Q dash, this behind the corner is not visible, inside the bracket Q dash. And in the top center point, we take it as O1 becomes inside bracket O1 dash, because when we are going to draw the front view, that center is not visible. In the bottom also, that center is not visible. O2 you written inside the bracket, and R becomes R dash. So this C becomes C dash, because the bottom corner is visible in the front view. Bottom corner is visible inside bracket, in top view C dash is there, in front view it is visible the C dash. And this D dash is also visible inside of, but in the top view it is not visible. In front view, that bottom corner D becomes D dash, and this B inside bracket B becomes B dash. In the front view, A becomes A dash. So this is the what we call it as, it is the front view of the square prism resting on one of its corner in the first position. This is the front view, that total height is clearly visible. In the top view, only top face is visible and bottom face is not visible. That bottom face not visible means bottom corners of the four corners are written inside the bracket. Okay, in the second condition, we are going to draw the line axis makes an angle of 40 degrees to HP. So on that, we are going to place its axis. Okay, you place the first position front view, that the square prism whatever you are obtained, that axis makes an angle of 40 degree, and its corner touches to the XY line. In this manner, you are going to place that front view in the second position. Just you have to tilt this axis makes an angle of 40 degree. Then you transferred all the text whatever you are mentioned in the first position front view. Okay, then you project the lines in the downward direction, projection lines in the downward direction from each end every corner of this front view. Okay, then you project this top view of the first position towards right. You are getting the intersection points, so then you can join the respective corners. So in the second position, tilted at an angle of 40 degree, when you are viewing from the top, this top face is clearly visible. This top face is clearly visible. That is P, Q, R, S are clearly visible, and the bottom face that is resting on the corner C is not visible, and that joining edges, that is CB and CD, are not visible when we are going to draw the second position top view. That edges are represented by dotted lines. Okay, this is the second position of the square prism in the top view. Then we are going to draw this axis, that is O1 and O2. This is the height of the square prism in the top view in the second position. This tilted at an angle of how much? 45 degrees to VP. So first we consider that O1 and O2 on the 45 degree line. With respect to that O1 and O2, we are going to we are going to move that whole object in the second position top view at an angle of 45 degree, and name the each and every corners in the second position as it is. So this indicates the axis of the square prism O1 O2 is appears to be, means directly we have to take it on the 45 degree. Appears to be means in the third position, the second position top view, whatever you are getting, we have to place it on the 45 degree without any changes. Directly we have to place it on the 45 degree. We call it as the object appears to be. Then draw the projection from each and every corner of the third position top view in the upward direction, and the second position front view towards right side direction. All the vertical and horizontal projection lines intersect. We are getting the respective points. Then we have to mention the points. But in the third position top view, this top face is visible. See, this top face is visible, the bottom face is not visible. In the third position, in the front view, we are drawn that the top face is not visible, bottom face is visible. So in the third position top view, this bottom face is not visible, while it is drawn in the front view in the third position, that bottom face is visible. This is the bottom face is visible, and top face is not visible. And invisible edges, we are considered the two shorter edges and one longer edges. These three lines are represented by the thick dotted lines. Okay, this is how we are going to obtain the third position front view of the square prism resting on HP on one of its corner, or two sides equally inclined to the HP. Okay, so I hope you understand this three position, how to draw the projection of the square prism resting on HP on HP, or two sides equally inclined to HP. So you go through this. So practice more. You must have the confidence. In the next class, I am going to explain the projection of that pentagonal prism. Okay, resting on corner and resting on one of its edge. So I hope you are understanding this. If you are having doubts, please call me back. I will ready to clarify your doubts. Everyone, already I had sending the assignments on assignment 1 and 2, that is projection of points and lines. You complete it. I will send another assignment on projection of planes. Okay, you don't waste time, concentrate more. I hope you are understanding all these things. Okay, thank you one and all.